Okay, Year 12. So this is the solutions for chapter collecting, representing and interpreting data. And this is assessment B. So question 1, data is collected by dividing a list of applicants for tickets to a music festival into groups based on where they live. Then a single group is picked to take the sample from. So we're asked which the name of the sampling technique. So we're given 4 different ones here. So simple random sample means everybody has an equal chance of being picked. Well, as soon as you divide them into groups and then only pick one group, not everybody has a single chance of being picked, so it's not that one. Stratified, when you're choosing groups, choosing a sample, then you are looking for the word proportion. So you want stratas such as age groups or gender, and you would pick your sample based on the proportions of those strata in the population. So if it was a 50-50 for male and female, then your sample should be 50-50 male and female. So we're not told it's based on proportion, so it's not that one. Systematic, we would label every person and then pick every nth person. We're not doing that. This is cluster sampling. Okay, the clusters are the areas that they live in. Okay, so we've divided the area into clusters, and then you've picked one cluster and taken the sample from there. So that's cluster sampling. Question 2. A group of bakers is surveyed to determine the average age of a baker in a particular country. In the group, the mean age is 41. Which word best describes the group of bakers? Well, the population is all the bakers. Okay, so it's definitely not the population because we're saying a group of bakers. Sample is a group from a population, so that is one word that would describe this. It's not a parameter because a parameter is a bit of information about the population, and it's not a statistic because a statistic is information about the sample. So it's definitely sample is the group. Okay, so question 3, I'm happy that everybody got that one okay, so we'll skip through that one. And question 4, again, we'll skip because everybody got that one okay. Question 5 is the one that causes problems. So we've got this data here. Okay, and you're asked to find the mean and standard deviation. It's only 3 marks. You could do this longhand. You could add up all the values and divide by how many there are to find the mean, and then square each value, add them up, divide by n, and take away the mean squared. Or you could use a calculator. So at the moment, I've only got one of these big calculators. If you've got the class whiz, just go onto YouTube and search for class whiz finding the mean and standard deviation to see how to do it. Or look back in your notes because we have done need to have notes on that. But if you've got one of these calculators, you need to be in menu 2. Okay. We're going to type the data, or I have typed the data already, into list 1. Okay, so we'll just scroll down list 1. You'll see it goes all the way down to 51 at the bottom. There are 12 bits of data there. Okay, now I'm going to calculate for this one. Okay, so I'm going to press calc. Now I need to check that my calculator is set up properly. So if I come to here, I want to check, first of all, that my data is in list 1, because that's where I've put it, yes. And secondly, that my frequency is set at 1. I've only got 1 of each number, and that's okay there. Okay, so that's okay, so I can press execute. Now I'm going to click 1 var, and it tells me the mean is 15, and the standard deviation is 15.93. But either of those are acceptable in an exam. Doesn't matter which, whether you use sigma x or sx. There's slightly different meanings, but examiners are happy to accept either because they're close enough. Okay, so let's go back to here. So there are your 2 answers, 15 and 15.3. Okay. On part B, you were given you were given some statistics, okay, and you were asked to find the mean and the standard deviation. So the mean is adding all the values up, dividing by how many there are. So that's your adding them all up is the 174. N was how many there are, so the mean is 174 divided by 12. A standard deviation, you add up all the values squared and divide by how many there are, so it'll be 13108 over 12, and then you subtract the mean squared. Okay, and you have to square the mean, and when you've got that answer, then you square root the whole thing. You don't square root these bits individually, you do all that calculation and you square root the whole thing. You should get 29.7. Okay, so depending on your previous answers, you will have written something slightly different to this, but I've given follow-through marks depending on how concise your answers were. So we're looking at how late buses are on particular routes. So if you've got a larger standard deviation, okay, that suggests less consistency in the times. So we've got here that B has a larger standard deviation, so it's less consistent than route A. However, the lower mean for route B indicates that it's late by a smaller amount of time. So to summarise, route B is late by smaller amounts of time but less consistently. Okay? Or you could say route A is more reliably late. You can guarantee A is going to be late more reliably than B, but B is late by smaller amounts of time but less consistently. Okay, so you've got to think about the mean and the standard deviation when comparing those. Okay, let's have a look at question 6 again. Just going to skip through. Everybody managed the first parts correctly, so we'll skip through to the last bit on this one. So, comment on the claim that households in Yorkshire and Humber purchase less chocolate per person per week than households in London. So we know that they purchased on average a lower proportion, because pie charts show us proportions compared to other confectionery, but not necessarily less. Okay, it depends on how many are in the sample for each region. So just get that sorted for pie charts, it's about proportion. So we're then looking at estimating median and quartiles from a frequency table, okay, or grouped frequency table. So first of all, we want to work out the cumulative frequency. So I've done that here to the side, okay. And so if we start with I think I've started with the lower quartile actually. So if we divide 38 by 4, okay, we get 9.5. So the lower quartile is the 9.5th piece of data. Well, I know the first 17 pieces of data are in here, so the lower quartile must be in this group here, 0 to 5. Okay, if I want to find the median, the median is halfway through, so that's 38 divided by 19. So I'm looking for the 19th piece of data. Well, the first 17 are here, and then it goes up to 27. So the 19th piece of data must be in this group here, 5 to 10. And then for Q3, okay, I'm doing 38 divided by 4 times 3, which is 28.5. So I'm looking for the 28.5th piece of data. Well, up to 27 are in this group, so the 28th is going to be in the next group, so 10 to 15. So I've just put these here so I know which groups I'm looking at for each quartile. Okay, so working out quartile 1, okay, it's the 9.5th. I know it's in the group 0 to 5, and I know there's 17 values going from 0 to 17. Okay, so I've got these two lines here. This one here is showing me the class width. This one's showing me the data, how many pieces of data in that class. Okay, and I'm looking for the 9.5th, so it's slightly over halfway. So I've put it about here, and that's my quartile. So the quartile is here. Okay, so I'm looking at if the 17th piece of data was 5, what was the 9.5th piece of data? Okay, so we're looking probably around 2.6, 2.7, maybe slightly higher, all right? Because we know it's slightly above halfway. So the way The way we're going to work this out is we're going to look at the distance between Q1 and the end here, okay, as a fraction of the whole distance. So that's Q1 minus 0 over 5 minus 0, and that should equal the fraction of the distance between 9.5 and 0 and the whole length here. So that's 9.5 take away 0 and 17 take away 0. So if we rearrange that, okay, so it's Q1 over 5 really, equals 19.5 over 17. So we multiply up by the 5, you get Q1 is 2.79. And that sounds about right because we said it was slightly over halfway. Exactly the same with Q2. Okay, Q2 is in the class that goes from 5 to 10. Okay, and we know that that starts at 17 and goes up to 27. It's 10 wide. Okay, 19 is close to 17, so I'm putting it this end. So Q2 is going to be closer to 5 than 10. So same idea. I'm looking at this ratio, the fraction of Q2 minus 5 over the whole length, which is 10 minus 5. So Q2 minus 5 over 10 minus 5, and that's equal to 19 minus 17 over 27 minus 17. So again, work these values out, multiply up, and then you would add 5 at the end, and you get that Q2 is exactly 6. Okay, but again, it matches where we think it should be. And then the last one, same idea. The Q3 is in the class 10 to 15, which goes from 27 to 35. Okay, so 28.5 is closer to 27, so it's down this end. So I'm looking at Q3 minus 10 over 15 minus 10, and that's equal to 28.5 minus 27 over 35 minus 27. And you get Q3 is 10.937. So you were asked for median and interquartile range. So the median 6, interquartile range is Q3 minus Q1, which comes out as 8.143. Okay, so that's your marks for that question, 6 and 8.143. Then you were asked to look for outliers. You just need to watch. Some of you are just not using that formula correctly. You're given the formula for outliers. It's Q1 minus 1.5 times the IQR. Remember, Q1 is this value here, 2.79. Some of you were using 9.5. 9.5 is the position of Q1, but Q1 is actually 2.79. So you should be doing 2.79 minus 1.5 times 8.143. And for this one, you should be doing 10.9375 plus 1.5 times 8.143. So it's just a case of choosing the right numbers to put into the formula, and you should come out with minus 9.42 and 23.15. Well, our data didn't go below 0, so this one is meaningless. But let's have a look at the table. Does 23.15 fit into our table? Let's scroll right up. So 23.15 would be in this group. There was one piece of data in this group. So that piece of data could have been below 23.5. We don't know. So all we can say is there is the potential that we could have one outlier. Okay, there are no lower outliers. There is potentially one upper outlier. Okay, you can't say any more than that. Okay, question 8. So again, most people got the correct answer here. It's negative correlation in context. The more caffeine-free drinks purchased, the fewer other soft drinks are purchased. Or if you just said it's negative correlation between the number of caffeine-free drinks and the number of soft drinks purchased, then that was acceptable. You're then given this regression line of y on x, and you're asked to explain what 0.56 it means in this context. So remember, the number in front of the x is the gradient, and gradient means for every 1 unit across, it's how many units up or down we're going. So going across, we're looking at millilitres of caffeine-free drinks sold. So to interpret it, it's for every 1 millilitre of caffeine-free drinks purchased per person, you expect a decrease of 0.56 millilitres in the quantity of other soft drinks purchased. So if we go across one, we're going down down 0.456, and we know it's down because of the negative sign there. Okay. Part C. So use the regression line to estimate the amount of caffeine-free drink per person. So you were given the regression line y equals 82. Okay, so you were given this regression line 82.7 minus 0.56x. So you're just going to plug 60 into that, rearrange, you should come out with 49.8. You have to get that exact answer because it's only worth 1 mark. And then we're asked about the response variable. Okay, so y is the response variable as it's dependent on C, and x is the explanatory variable. So if we just go back to the graph here, okay, we are looking to see whether the sale of caffeine-free drinks affects the sale of soft drinks. So the soft drinks is the response, okay, so y is always the response, and x is what we think is explaining the response, so that's your explanatory variable, okay. So that's just worth learning. Y is the response and x is the explanatory or independent variable. Okay, question 9. Okay, now a few people didn't read the question very well and put more towns than they should have. So it definitely says that you're only selecting 4 towns, and a few of you selected 5 towns. So just be aware of that you're reading the question carefully, and when you've got your answer, just double check you've got the right number. So there were 20 towns, so we want a fifth of all towns. So if you do 20 divided by 4, you're picking every fifth. Don't forget that you have to randomly select your first one, but please note this, it's randomly select a number between 1 and 5. It's not just randomly select any number, and you do need to say that's what you've done. You can't just say I'm going to start at 2. You need to say I'm going to randomly select a number between 1 and 5. There's a mark there for that. Okay, and then there's a mark for getting a correct list. So you select every fifth town, and then there's 2 marks for getting a correct list. So just make sure you write the list down. Explain why not all possible samples are equally likely to be generated this way, and give the name that describes a sample where every possible object has an equal chance. So I think everybody got the name of the sample, which was the simple random sample, is where everything has an equal chance of being picked, but not everybody was sure why we couldn't get all possible samples equally likely to be generated. Simple reason is once you've selected the first town, the other towns in the sample are fixed. They can't change because you're every fifth. Okay, so another way of explaining that is once Alfriston is chosen, the probability of choosing beta town becomes 0. Okay, so once you've picked the first one, there are some in that sample that are never going to be picked, and there are some in that group that are always going to be picked once you've picked your first one. So it means it's not random. It's not a simple random sample. Okay, question 10. Generally well answered. So this one, what was the median height of a seedling after 2 weeks? So there were 50 seedlings. For some reason this has come off. So your median is at 25, and so that comes out at just under 9. So 6, 7, 8, yeah, so about 8.9. The answers allowed anything from 8.5 to 9 centimetres. Okay. Use the cumulative frequency diagram to complete the table and calculate the variance in the height of the ceiling. So you need to complete the table first. So h equals 0 comes from here. but we also know the difference between 0 and 5 is 6. Okay, so if that's 10, that's 5. This is likely to be 2, and then 2 would go up to 8, which looks about right because it's slightly higher than halfway between the two there. Okay, so this has to be 2, which makes this 8, and if that's 8, then the difference between these two would be 22, and so on. Okay, so these are the answers here. If you didn't get them right, okay, as long as you get at least one right and your answers add up to 50, you get one of the marks. Okay, but obviously it affects everything else. So then you're asked to calculate the variance. So okay, so I've got my calculator here. Again, I'm in stats mode. I've got my lists. I've typed the midpoints into list 1. So you can see there, if I go to the top, 0, 2.5, and so on, and then the frequencies into list 2. So I need to be in calc, so that's F2, and I'm going to check my setup. So my midpoints, my X list is in list 1. At the moment, frequencies are set to 1. So in other words, it's saying that frequency is all 1, which is not what I want. So when I come to frequency, if I just go down to frequency, I want to tell the calculator that all my frequencies now are in list 2. Okay. So now it's got my data in list 1 and my frequencies in list 2, which is what I need. Now I can exit that, execute, press 1 var, and my mean and my standard deviation will come up. So on this calculator, I can only get my mean and my standard deviation. So I would need to take my standard deviation, okay, which is the larger of the two, this one, and I would need to square it, okay, to get the variance. Or what you could do is it gives you sigma x squared, which is 5,000. It gives you n, which is 50. So you could take those values and put them into the formula. So do 5,000 divided by 50 minus 9 squared. Okay, so 5,000 divided by 50 would be 100, minus 9 squared, which is 81, will give you 19. So you get a variance of 19. So that's the other way. If you don't want to worry about squaring these numbers, then just use these statistics here, the x squared, the n, and the mean. Okay. So that's that one. So please go through this in detail. Make sure you learn the things, and please, please, please learn how to use your calculators. If you've got this one or if you've got the class quiz, it is crucial for the exam. Okay.